Welcome to final episode of hardware development series. In this video, I'm going to test this PCB which is already assembled in the previous episode. Now I will perform continuity checking test for this PCB. If we damage any track or pad while soldering, that can be identified here. And also, we will test the final product, lithium-ion batteries recharge hub, whether these 4 batteries will get full charge or not. If yes, how much time does this will take to recharge the 4 batteries? So let's find out now. Before jumping into the episode, let me thank my favorite PCBware manufacturer, PCBware.com, for sponsoring this video.
PCBware.com is one-stop solution for PCB prototyping, manufacturing and PCB assembly. If you are using very small SMD components on your PCB, you cannot solder those tiny parts on the PCB. I have struggled a lot to assemble this PCB, but finally I have managed to do it. Later I came to know about assembling services of PCBware.com and get this done very easily with few mouse clicks. You can get your PCB assembled easily from PCBware.com.
The next step is to perform the continuity check. This test will determine if there is any short circuit between the two polarities and continuity between the same polarity pads. If we damage any track or pad while soldering, that can be identified here. I'm gonna use my Fluke 15B Plus digital multimeter in continuity configuration for this test. The test results are positive. There is no short circuit between the opposite polarity pads and there are no damaged tracks. So it's time to celebrate. Yeah. The next step is to place the batteries and test this recharge hub. So let's do that. We have to make sure we are placing the batteries with the right polarities. Otherwise, we will host Diwali here. The batteries will get heat and may blast sometimes if they are connected in reverse polarities. So we have to be careful while handling with batteries. The 4 18650 lithium-ion batteries are placed in the battery holder as shown here. Let's connect the input power supply and see whether it will charge the batteries or it will host the Diwali. Yeah, the switch is turned on and the charge controller started glowing the red LED. This means the batteries are being charged. It is a piece of good news for us. But the bad news is the input LED is not glowing. Maybe this one is defective or there will be some connection issue. So let's debug now. Soldering the new through-hole components on the desoldered through-hole pads will be like hell, because the pads will fill with the previous lead and we have to use a suction gun to take out the previous lead. That will eat our patience and precious time. After 10 minutes of struggle, I have replaced this red LED with blue one. Now let's connect the input power supply and test it again. Yeah, now this is working fine. And this proved the previous red LED is a defective one. It is always a good practice to disconnect the input power supply or the batteries while debugging something on the PCB. So I removed all of them. Now let's turn off the power supply and add the batteries again. As you can see here, there is a positive and negative terminal indication on both battery and battery holder as well. Just follow that and add the batteries. Let's apply the input power supply. Now the charge controller is glowing red LED, which is indicating the batteries are being charged, and the status LED is also glowing perfectly fine. Thus, the mission is accomplished. We can simply disconnect the battery or stop charging the battery by simply removing this jumper. Whenever I remove this jumper, the charge controller status LED turned to blue, which means there is no current flowing through it. If the battery is disconnected or the battery is fully charged, the amount of current flow through this module will be 0. That's why it will show a blue LED in both cases. If I connect it, the LED will turn to red. The only thing left is charging the flat lithium-ion batteries. We can easily connect them using the battery connector provided here. So the batteries are also charging very well. The final test. Are these batteries will get full charge with this recharge hub? If yes, how much time it will take to recharge these 4 batteries? Let's find out now. Currently, I am using 5 volts 2 ampere mobile charger and all charge controllers are connected parallel to each other. Each charge controller is capable of delivering 1 ampere, but due to 2 amperes input power supply and parallel connection, each battery can get only 500 milliamperes of current, and the battery is having 2600 mAh capacity, so it should take around 5.2 hours to charge the battery. Let's wait and see how much time it will take. So after 4.5 hours, the batteries are fully charged. It is quicker than the calculated one. I think these batteries are not fully discharged before we charge them. That's why they have charged fully before the actual time. With my knowledge and experience, I can say this recharge hub will take around 6 hours to charge the total of 4 batteries with 2 amperes input power source, because the current flow will not be ideal as are theoretical calculations. There will be some fluctuations, so these fluctuations will lead to consume more time than calculated one. So charging these 4 batteries within 6 hours is okay for me, because I would like to use these batteries for IoT devices, not for the electric vehicles. I have the bandwidth to wait 6 hours until the batteries are fully charged. If I need these batteries to be charged in lesser time, we can still use the 4 amperes Whoop charger, which will reduce the charging time to around 3 hours. Now let's see the voltage of each battery after the full charge. I'm gonna use Fluke 15B Plus digital multimeter in DC voltage configuration to measure the voltage of each battery. The green battery B1 has 4.161 volts. The pink battery B2 has 4.188 volts. The blue battery B3 has 4.206 volts. Another pink battery B4 has 4.172 volts. So all the batteries have almost 4.2 volts, which is the maximum voltage level for lithium-ion batteries. Thus, the mission is accomplished. That's it for this tutorial and hardware development series. In this journey of hardware development series, we had gone through the component selection and circuit designing of lithium-ion battery recharge hub. Also, PCB designing with RTM Designer and PCB manufacturing and its 18 stages of fabrication process at PCBware.com. Finally, we have experienced the DIY PCB assembling process and testing of the hardware after assembly. I hope this series helped you to learn the basics of hardware development. This is just an ignition through hardware development and a lot to discuss. I haven't gone through it very deeply because that will make things more complex and you will not understand them on the first go. This is just a trailer, a big picture back here. So, see you soon on the next interesting episode. Bye bye.